Let's say you came across this question in your chemistry exam. How will you solve it? It is very easy. Now let's solve together. The question says, calculate the enthalpy change. This particular aspect in this question is very, very important. From the question, they are asking us to calculate what? The enthalpy change for the reaction below. Alright, this is the reaction. This question is extremely very easy. Ensure you listen carefully to the way I'll be solving this question, and at the end of solving this question, I'm going to give you a practice question to solve so you can master this aspect of chemistry properly, because it is very, very easy. Moving further, what do we do? Now, relax. Leave this aspect first in this question. I'm going to explain it, all right? We have to focus specifically on what we are asked to calculate for, which is enthalpy change. Now, first of all, before we talk about enthalpy change, we have to talk about first what enthalpy itself is all about, all right? Before we talk about enthalpy change, we have to note what enthalpy is all about. Now, this must be noted. Enthalpy in chemistry is symbolized as H. And what is enthalpy? Enthalpy is simply the heat content of a reaction. I believe you are following me. As we're having enthalpy, which is symbolized as H, so we are having what we call enthalpy change. Are you there? You know, whenever you see change in science, it is symbolized as delta with this sign. Are you there? So enthalpy change itself will be symbolized as delta H, which is change in H. All right. Remember, we said already that this H is the enthalpy of a reaction, which is the heat content of a reaction. Now, moving further from this question, listen carefully. Note this. This enthalpy change we are looking at, which is symbolized as delta H, can be of two kinds. Enthalpy change in a particular question can be positively charged. Enthalpy change in another question can also be negatively charged. Listen carefully. Let's say, for instance, the enthalpy change of a particular reaction. We have not yet solved this question. I'm just assuming. Let's say, for instance, the enthalpy change for a particular reaction is positively charged. We simply say that, listen very well. Let's say the enthalpy change of a particular reaction is positively charged at the end of solving all of the calculation, which I'm going to teach you in the course of this question. Let's say at the end you had a positive value. It simply tells you that that reaction is endothermic in nature. Please listen. Whenever you are solving for your enthalpy change, because it has a formula you should take note of, which I'll be teaching you in the course of this class lesson. So let's say, for instance, this enthalpy change is positively charged. We simply say that that reaction is endothermic in nature. Please listen. If delta H in a reaction is positive, that reaction is what? Endothermic in nature. But let's say, for instance, delta H is negatively charged, all right? Delta H in a reaction is negatively charged. We simply say that that reaction is exothermic in nature. Now, what do I mean for a reaction to be endothermic? It means that in that reaction, this heat we are talking about is absorbed. Remember, enthalpy is the heat content of a reaction. But for endothermic reaction, the heat is what? Absorbed. Whereby for exothermic reaction, the heat is given off to the surrounding. I believe you now know the difference between an endothermic reaction and also an exothermic reaction, because we need all of this knowledge to tackle this question, because this question is extremely very, very easy. Now, moving further, this delta H, which is enthalpy change, has a formula we must take note of. And that formula for delta H is delta H is equal to, listen, HP minus HR. I know the question you want to ask me, what does HP means? And also, what does HR means? Now, listen carefully. HP, you know, H itself is heat, or enthalpy. We said that already. This H is heat or enthalpy, all right? So this HP, the P here is product. The arrow here is reactant. Now listen very well. I believe you are aware that in a chemical reaction, we have two sides. We have the right-hand side of a reaction, which is this side, and that right-hand side of a reaction is simply called the product side, whereby the left-hand side of the reaction is called what? The reactant side of that reaction. Now, HP here simply means heat content of product, all right? HP here simply means heat content, listen carefully, heat content of products. We were given in this question, relax, whereby H arrow simply means heat content of reactant, because we saw what? Arrow. Now, what do we do next? It is very easy. It's just for we to locate our product side and the reactant side in this question. And what forms our product and reactant? Listen very well. In our product side, we have CO2 and H2O, whereby in our reactant side, we have CH4 and this, which is oxygen, O2. All right. So what do we do next? If you observe carefully, we were given the standard heat content of these substances that formed this reaction. Please listen, the way I'm solving it, this is the way you should solve other type of questions when you see them in your exam. At the end of solving this question, I'm going to give you a practice question so you solve and provide the answer in the comment section. So moving further, remember what we're looking for is delta H, which is the enthalpy change. And the formula is what? HP minus H arrow. This is HP, this is H arrow. So first, before you bring them together and subtract, you have to calculate individually for your heat of product and your heat of reactant in this reaction. So let's quickly come here. So HP is heat of product. What are my products? Listen very well. My products are CO2 and H2O. So I will look for CO2 and H2O in these particular informations. And from the look of things, we want to solve for the heat content of the product first. So for CO2, look at the heat content. Listen very well. I'm going to bring it down. All right. CO2 is what? Minus 349. Please listen very well. Whereby for water, H2O, it is what? Minus 286. So what then do we do next? Listen. Normally, for us to calculate for our heat content of product first, we simply add. They were part of the product. So for you to get their total heat of product, you add them together to get your total heat of product. Are you there? But you don't just do that. You have to be careful about the values, the moles of these substances, be it an element or a compound. Now for CO2, whenever you are balancing a chemical reaction and you don't see a value written in front of these compounds or elements, you assume it to be 1. There is an invisible one here that we cannot see. There is an invisible one there. So what next do? We simply come here for CO2. Since I told you already, there is an invisible one here. We simply come here and say times that one. Please listen very well. This thing is very easy. For water, you have to be careful. Are you not seeing it has 2 moles of water? That moles, you use it to multiply the heat of that substance. For water, it was 2 moles it has, so you use it to multiply. Are you there? Remember, these 2 substances forms the product. You don't just pick them the way it is and add them together to just get your heat of product. You have to be careful about the values written in front of them. All right, so that you use them to multiply first before you bring them down to your heat of product. So you can see what we've done. So let's multiply and get the total heat of product we have to put down. So what next do we do? Listen very well. So rewriting for CO2, it remains minus 394 times 1 is still itself. Whereby for water, it's going to be minus 572. I believe you are following me. Remember, we are going to add them together. You add that, guys, in your product and so as your reactant, and then subtract them to get your what? Delta H, which we have talked about. So let's add them together to get our total HP, which is the heat of product. So when we do that, we are going to get minus 966. All right. Remember the unit kilojoules. All right. Kilojoules per mole. So this we've gotten is the total heat of products we are to impute here. So delta H will now be equal to minus 966 kilojoules per mole minus, are you following me? So the next thing for us to calculate is the HR. The way I calculated for the HP, which is the heat content of products, it is the same way you have to calculate for the HR. So let's solve together. First of all, we identify our reactants. These are our reactants, CH4 and 2O2, all right? So let's calculate for the HR. For CH4, it has its own standard heat energy, all right? And from what we're given, CH4's standard heat energy is minus 75. Remember, the unit is kilojoules per mole. Moving further, we'll simply write for the other, which is O2, all right? The way they wrote it, that's how we write it. So for O2, it is 0 kilojoules per mole. Remember, for we to get the HRO in total, we add the energies of our reactant side together. Remember, at the end, we are going to subtract, all right? But for we to get the individual values, HP, HRO, we add for our products, we'll add to our reactant and then subtract them together. So the next thing to do, remember, before we, add them together, we'll multiply them with their mole ratios, all right? For CH4, remember I told you that whenever you're not seeing any value standing in front of a compound or an element, you assume it to be 1. There is an invisible one here. Even though you're not seeing it, I am seeing it. There is an invisible one. Take note of it. So moving further, for this minus 75 kilojoules per mole times by the one we are seeing here, whereby for oxygen, it has 2 moles, we'll times this, the energy, we'll times it by 2. Are you there? Moving further, what next we do? Let's, get our values. So for CH4, it remains the same, all right? Minus 75, because minus 75 times 1 is minus 75, whereby here is 0 kilojoules times the 2, all right? And it is 0. Anything times 0 is 0. I believe you know that. So for oxygen, O2 is going to be what now? 0. So what next we do? We'll add these values together the way we did it for the each of product, all right? When we add them together, the total HRO becomes minus 75 what? Kilojoules per moles, all right? Because minus 75 plus 0 is same value. So what then do we do next? We simply bring the value down to the heat of reactant. Remember the formula is what? Minus 966 kilojoules per mole minus this HRO, which we've gotten to be minus 75. But to prevent any problem, I'll put it in a bracket. Are you following me? So then moving further, delta H will now be minus 966. In mathematics, minus times minus bracket means times, all right? Minus times minus, that is plus, all right? Minus 966 plus 75. What are we getting when we hit our calculator? Delta H, which is the enthalpy change the question is asking us to calculate for, becomes minus 891 kilojoules per moles, all right? Because minus 966 plus 75, we are going to get its value. Moving further, listen very well. You can see here that the value we've gotten, remember I told you guys that for delta H, it can be either positive or negative. If delta H you have solved for is negatively charged, it tells you that that reaction is what? Exothermic. Heat is given off to the surrounding. But if it is positive, it means that heat is absorbed by the system or by the reaction. So in this case, delta H was negative. It means that this reaction they gave us in this question is what? Exothermic in nature. I believe you are following. They are all very easy. So what becomes the answer to this question based on the options given to us? The answer becomes option C, because option C has minus 891 kilojoules per mole, not this positive value. You have to be careful. They are the same number, but the signs differentiates them. So you can see how all of these questions are being solved without stress. Get ready for your own practice question. Okay, guys, here is your own practice question. You can see I've changed the reaction and also I've balanced the reaction. This is 2 carbon, all right. This is 2 oxygen, 2 oxygen altogether. 4 oxygen here is 2 times 2, 4 oxygen. Reaction is balanced. They've given us the energies of these guys forming the reaction, all right. This is CO heat content. This is oxygen heat content. This is carbon dioxide heat content. So ensure you solve carefully and provide the answer in the comment section. We've come to the end of this video lesson. If you find my video lesson helpful, make sure you click on the subscribe button to my YouTube channel and also share my lessons with your friends. Thanks for watching.
To have more understanding about chemistry calculations and solving all of these type of questions, I already have them on the chemistry masterpiece, okay, which is calculations and keynotes in chemistry. So if you are preparing to write the JAM exam, this book is very, very important for you. Now, for more information getting the chemistry masterpiece, do well to direct message me via my WhatsApp number. It will be on the screen.